Hi, my name is Rafiq Hariri Birazami.
My name is Adina Shaira binti Araman.
My name is Nur Alia Natasha binti Maisir.
Hello, Assalamualaikum. My name is Adina Shahira. I am from Group 3, and today me and my group are going to present to you to the topic about techniques of differentiation. So first, I'm going to explain the meaning of differentiation. Differentiation is the process of finding the rate at which something changes. Like, for example, when you are driving a car, the speedometer at the front is changing over time. So basically, differentiation is the mathematical way of figuring out that kind of change. So I'm going to explain the first rule, which is constant rule. So in constant rule, the derivative of constant number is always zero. A constant doesn't change. It stays the same no matter what the input is. So basically, its rate of change is zero. To make it easier for you to understand, if the number has no x, we don't know the value, so we call it real number. After you differentiate that real number, the value would be zero. So if you differentiate constant number, for example, like 2, 5, -9, or 7, the answer is always zero because the number doesn't change even though the value of x always changes.
Let's look at power rule. Power rule is used when differentiating function of the form. Let me explain based on the example. First, you need to bring the exponent down, then multiply it with the coefficient. Lastly, just reduce the exponent by 1. Simple, right?
Next, the constant multiple rule. The constant multiple rule is used when a function is multiplied by a constant. The first step of constant multiple rule is to bring down the exponent and multiply it with the function and reduce the exponent by 1. So the next technique is sum and difference rule. This rule is used when there is addition or subtraction between the function. So to solve the question using this rule, we need to differentiate each function separately.
Next, let's look at product rule. Product rule is used when differentiating the product of two functions. Product rule has a very simple formula, which is uv prime plus vu prime. Let me explain the step based on the example. First step, label each term as u and v. Second step, just differentiate both terms u and v. Third step, substitute the value into the formula. And lastly, expand the terms and simplify the expression. Next, we go for quotient rule. Quotient rule is used when differentiating a function that is the ratio of two functions. Quotient rule also has a formula, but it's a bit complex, which is vu prime minus uv prime divided by v squared. Let me explain the formula based on this example. First step, we need to label the dominator and denominator as u and v. Second step, we need to differentiate the both of the term. Third step, substitute the value into the formula. And lastly, simplify the expression.
The last technique is chain rule. This rule is used when there is a function inside another function or known as composite function. The first step is to bring down the exponent and copy the function and reduce the power by 1 and differentiate the function. For the first question, I use the product rule. I use the product rule because the expression involves two functions being multiplied, which is 4s and cosec 1 plus x. First, I identify the function, which is I let u equal to 4s and v equal to cosec 1 plus x. Then, I identify the derivative of the function. Next, I use the product rule formula and substitute the values in the formula and get the final answer. For the second question, I use quotient rule. I use quotient rule because both numerator and denominator have the variable s. I let the numerator be u equal to sin x and the denominator will be v equal to 3x plus 2 to find the derivative. After found the derivative, I use the quotient rule formula and substitute the value into the formula. Lastly, I simplify and get the final answer.
For question 3, for the first step, we need to separate each term into A, B, C. Then differentiate each term with differentiation technique. For term A, we use product rule since these have two terms multiply with each other. After finding U and U prime, we continue to find V and V prime. For V prime, we need to use chain rule to differentiate. After that, we finish up our product rule by using formula VU prime plus UV prime. A prime will be dy dx ln x squared plus 2y over x. For term B, we will differentiate this term using chain rule. B prime will be 2e x plus 1. For term C, we will differentiate using chain rule for trigonometry. For this step, we need to differentiate every term in the trigonometric equation. C prime will be negative 4 sins for y dy dx. For the next step, after differentiate all the terms a, b, c, we need to put it in the equation to finding dy dx. Write the whole differentiate term into equation. After that, we open the bracket with the following plus or minus sign. Since we finding dy dx, separate the dy dx term with other term. After that, we need to factorize the dy dx equation. To get the value of the dy dx, we need to dividing the bracket terms.
In this question, we use linear approximation. First step is to identify x0. Choose a convenient value of x0. Make sure the value of x0 is close to x. In our case, x is 80.99, so we choose 81 as x0. Next, we find the value of the difference of x, which is delta x equals to x minus x0. Afterwards, we need to find the value of fx and f prime x. For fx, we replace the value of 18.99. Then, we differentiate fx. In this case, we use constant multiple rules. Next step is we need to find the values of fx0 and f prime x0. So fx0 equals to f81, which is we take the value of x in the first step and use the equation we got from fx and f prime x. For the last step, we use the formula, which is fx0 plus delta x is approximately approach to fx0 plus f prime x0 multiplied with delta x. For the last answer, we take 3 decimal and get 2.0778. For confirmation, you can insert this question in calculator.
For the conclusion, differentiation is a fundamental concept in calculus that helps us understand and measure how quantities change. By mastering essential techniques such as the constant rule, the constant multiple rule, sum and difference rule, power rule, product rule, quotient rule, and last but not least, the chain rules, as well as learning how to differentiate trigonometric, exponential, and logarithmic function, we can approach and solve a wide range of real-world and mathematical problems with confidence.